Okay, so to continue then, as we start talking about the mole and how this number can help us out in chemistry. So if we remember, 1 mole is equal to 6.02 times 10 to the 23rd atoms or molecules. And so we talk about we use this number, as we said, because atoms and molecules are so tiny that it's kind of hard to count them. And the mole kind of gives us a good benchmark for that. So one of the main things that we can use this number for, though, is to allow us to jump back and forth between mass of something and moles of something. So let's go back to our periodic table, and we'll go back to carbon. You got the name at the bottom, atomic number, which is how many protons, your symbol, and then in the top left, 12.011. And so what that number is, that 12.011 top left, is the atomic mass. And it's equal to, as we can see, 12.0111. Might be a little bit different depending on your periodic table, but it's always going to be kind of right in that area there. Atomic mass of carbon. But what that number also is the molar mass of carbon. And when we're talking molar mass, it's that same number that we see in the top left. But we have a different unit for it. And the unit is grams per mole. So for carbon, it has a molar mass of 12.0111 grams per mole. And it's just important to remember that we have this, when we're talking molar masses, that we have this unit, gram per mole, at the back of it. So we've talked about moles and we've talked about masses, so really kind of want to visualize and think about how they're related. So say we go into the lab and we pull out our balance. It might look kind of like this. The balances are sometimes different. But anyway, say it pretty much would look something like this. And we'll have our readout here for the mass that it records. So we've got the balance, and we put a weighing boat on top of it, just a piece of plastic, kind of basically something to hold it. And then what we do is we start to add atoms of carbon. To that weighing boat. So we start dropping in atoms. This isn't realistic. We wouldn't actually be able to do this in any of our chemistry labs. Actually, there are, and it would be very time-consuming as well because atoms are tiny. But we start doing, we're pouring in atoms, adding them up, and they're just kind of settling to the bottom, starting to add up over time. So we keep adding them, and we're going to add them until we have put in 1 mole. So we're adding 1 mole, or 6.02 times 10 to the 23rd atoms. So it's going to take a while, but that's a lot of atoms. So we've been doing this, and we've poured in all of these atoms of carbon. So we come over here, and we look on our scale, and what do we think that the mass is going to be? Well, as you may have guessed, The mass on that scale will read 12.0111 grams. And so when we talk molar mass of carbon 12.011 grams per mole, what that means is that if we add 6.02 times 10 to the 23rd atoms, add 1 mole, we put that on a scale, on a balance, that's what its mass is going to be. 12.011 for carbon, or whatever that molar mass, that atomic mass, is in the top left corner.